Welcome to Answer Everywhere. Today we are looking at RabbitMQ, which is a distributed message broker written mostly in Erlang. Or at least that's what they want you to think. It's written mostly in Starlark because at least this RabbitMQ server repo is largely configuration for Bazel. We can pop open the Bazel build file here and very slowly GitHub will load it. What I see is that it's not entirely readable. So let me maybe scroll out and give some more screen space to this. They defined a bunch of their rules, and they have these things like homes and plugins, and like it's not clear to me where broker home is. It doesn't have at least super clear to me reference to a thing on the disk. But I did take a look-see around the repo, and it seems to me that the way it's laid out is that the real code for Rabbit is in deps. And calling it deps makes it kind of seem like these are dependencies that are somehow vendored in, but I didn't find a better repo for what appears to be the actual Rabbit code, which is in RabbitMQ server /deps/rabbit/source. Maybe if we look at the commit messages, I don't know if there's any sort of indication that this is pulled in from some other thing. There's certainly not Git submodules or anything. So I'm going to guess that this is just where things live. All right, and so we'll just explore from here, from dep/rabbit. And I'm supposing that most things are in source. And I've never looked at Erlang before. I don't think I've ever in my life seen an Erlang file. So we're gonna have to try to figure out what it is that that Erlang is up to, and try to read through the syntax. So I do know a couple of things about Erlang that, such as immutability and using kind of a I don't know if it's literally CSP, but basically processes are cattle and not pets. Their processes are easy to create and to spin up and to kill, and there's some idiosyncrasies of the syntax, like having to end lines with periods as opposed to the traditional semicolon or nothing at all. So hopefully we can flub our way through. So here's CSP for the folks not in the know. Is Erlang one of these? It influenced the design of programming languages such as Limbo, Raftlib, Erlang, Go, Crystal, and Clojure's core async. And it's a formal language. I'm sure the original paper is fun, but that's not what we're here for, man. Okay. I'm going to guess rabbit.url is an important thing. AMPQ is the standard, right, for message brokers. So if you're not familiar with RabbitMQ or message brokers, then you can kind of think of it as it's a system to coordinate messages between like apps or tasks, or there's kind of the same pattern in microservices. You can think of it a little bit like an email exchange. And if you had something like a chat system, you might use RabbitMQ to ensure fault-tolerant message delivery to all of the different chat clients. So you might have the same person logged in on like two different mobile phones and the browser on a desktop machine, and maybe something else on a laptop. And you want to make sure that they all get the same messages in the same order and all of that sort of stuff. And that's handled by some middleware that is message passaging. So AMQP, the Advanced Message Queuing Protocol, is an open standard application layer protocol for message-oriented middleware, which is what we are. The defining features are message orientation, queuing, routing, including point-to-point, and publish and subscribe, reliability, and security. Okay, so these are the sorts of things we're doing. All right. Okay, so here's rabbit.url, but let's go ahead and open a few other files as well. Okay. I guess we'll open this AMQ queue. Presumably the queue is the same as the queue here, but spelled out. There's some stuff about auth mechanisms, which might be interesting, but I'm going to guess is not super interesting. Auto heal might be interesting because that might be about fault tolerance, which is something that you probably want to reason about in a system like this. RabbitBasic. I don't know what that's going to be about. Channel stuff, channel interceptors. Yeah, let's look at channel. Let's look at a channel interceptor, which is presumably going to maybe possibly stand in front of a channel and do something like filtering. We have channel tracker, client sup. I don't know what sup is. Support, supreme. We have connection tracking. I'm not sure about that. Core FF. I don't know what FF is, but cuttlefish, sure. DB is presumably persisting messages to the DB. RabbitDB policy, RabbitDBQ. Let's look at DBQ. Topic exchange. I'm going to guess this is, so the Rabbit has a couple of different kinds of what it calls exchanges. So you can model Rabbit basically as a list of queues, and you can think of a queue as kind of like a mailbox. So I believe mailboxes are literally queues in this sense, but there's also like, the print queue, which is you send print jobs and they kind of live there until they're executed. So you can think of Rabbit as having a bunch of queues. And then there's like a router, which is maybe you can think of a little bit like React router or something, where messages first go to this router, which is called an exchange. And the exchange decides which queues to put the messages on. And then the clients somehow read from the queues. So the exchange is kind of like a thing in front of a bunch of queues. Let's see if we can find a diagram. Something like this, maybe. Here's Cloud AMQP, which is presumably more or less the same. I think this is Rabbity. Yeah, we got RabbitMQ down here. So we have a producer, which is, I'm going to guess, is a thing that produces envelopes and or messages. And these are different types of exchange. So direct exchange, you essentially have a key, a routing key. I'm not sure what they call it, but kind of like an address, or that says like @answereverywhere at whatever.com. And that key is used to decide where to route things. In a direct exchange, I believe what happens is it goes directly to the queue that matches that particular key. For a topic exchange, you do like prefix matching. So if I'm interested in, I guess, EU.de, which presumably is messages about Germany, this will route anything that has that prefix to this queue so I can subscribe to it or whatever. And then fan out is you want to replicate the message to all of the queues. So we should see some of that. But at any rate, what I wanted to point out was that's what the exchanges are about. And then the queues are kind of down here underneath the exchanges. All right, I see some virtual host stuff. I don't care too much about that. I'll look at exchange type, and let's look at the implementations of each of these exchanges. Fan out headers. I think headers does something with routing based on the headers. Maybe HTTP-like headers. I don't know, or TCP, I suppose. We have feature flags, which is mildly interesting, but we're not going to look at. We have FIFO, which will presumably be a FIFO queue, but now we have an HRL file. What's an HRL? Is it like a header? What is an Erlang HRL file? A header file, akin to a C include file. Okay, so some header file. Maybe it can reduce our load if we look at a few of those. But let's look at maybe FIFO and FIFO DLX. Rabbit file. We don't need GUID. We don't need limiter. I'm going to guess some sort of rate limiting. I suppose let's look at that just for fun. Logging. I think that because of the way Erlang works, I think that there's not a central log. So there's presumably some sort of distributed log. I don't know how it works, but I'll open a few of these log things. Rabbit logger exchange, header, or no, .url. I don't know what that's for. Looking class has an interesting name, but I'm going to guess it's about maybe observability, monitoring, metrics, logs, that sort of thing. And then we have mirror queues. I don't know what makes it a mirror, but we'll ignore that. We'll look at message record, message file. Where did message file go? RabbitMQ, I'm going to guess is some sort of amnesia. Maybe it's something that's in memory that goes away, doesn't persist. Maybe we'll look at it. I guess we'll look at networking. Nodes. Yeah, sure. Let's look at nodes. Did I open that? Okay. Policies, plugins, I think we'll ignore. I want to make sure we get whatever the main queue thing is. So here's queue consumers. Here's queue decorator. I suppose we should look at process. Then we have queue index and queue location. And queue type. I don't think we've seen queue type. We've seen exchange type. A quorum queue. I don't know if that means that like some quorum has to agree before something happens. And we'll look at Rabbit router. SSL, I'm going to guess, is just support for essentially TLS at this point. A stream coordinator. I guess let's look at the stream coordinator header and the stream queue. Whatever a SAC coordinator is. More sup stuff. Again, I don't know what sups are about. Table. I'm going to guess tables are not the most important part of this. vhost, I'm also going to guess is not so essential. We have a VM. I'm going to guess this is like the Erlang VM. Might as well open it just to see if there's anything important about it. All right, so let's plow along. Hello. Sorry, I missed this message. Let me pop this on out here. Where is here we go. So if Takar is asking, do I ever plan on read how Erlang does Erlang's distribution work? I'm not opposed to it. I haven't currently planned it, but I'll write that down. Is that the same as just understanding Erlang in general, or does distribution mean something in particular? All right. Also, if you're watching now, let me know how the audio is. Like, how's the volume? Is there audio interruptions? That would be super helpful. Okay, so let's take a look at these files, yay. So here's rabbit.erl. I'm going to guess this is one of the most important files. This, again, I've never seen an Erlang file in my life. I'm just going to guess that this is just the syntax for defining the module. We're including a bunch of stuff, presumably modules. Behavior application, I'm guessing, is saying it's a kind of app as opposed to something else. Let's see if this is an Erlang thing. Behavior. Erlang OTP behaviors for beginners. The behavior interface, which is a set of functions. Okay. The implementation is a callback module, the behavior container, which is a process. So here's an example, gen server. Okay, this is like too far in depth. Erlang behaviors and how to behave around them. Okay, so you know what I'm going to do is I'm going to just ask the AI, which I'm treating essentially more or less like a search engine. I'll say, what's the deal with behaviors in this Erlang program? The behavior directive is used to define that a module implements a certain behavior. Is that kind of like an interface? They provide a way to structure Erlang code and enforce certain patterns or interfaces. It has an application directive that indicates that the module in which this snippet is placed is expected to implement the application behavior. So is this to an interface in a language like Java? Yes. Okay. So I'm going to think of it as basically an interface. I don't know if application is a Rabbit specific interface or if it's a general Erlang thing. We're exporting a bunch of stuff. This is kind of like familiar from Haskell. I think Erlang predates Haskell. Or maybe they're about the same time. Erlang, I think, is the 80s, right? 1986. Okay. So I'll say create an image of a 1986 programmer in where? Ericsson is what? Where is Ericsson? It's one of the ass countries. Is it Sweden? Swedish. In Sweden. So let's say create a synthwave. Okay. So interface is interface. We'll come back to you, Gemini. And then Haskell is when? 1985? So that's close. What was that's a different thing. 86. Okay, so Haskell, it sounds like maybe predates. Oh, no, Miranda is 1985. Haskell is when? I thought that didn't sound quite right. 97 is Haskell 98. Haskell 1.0 is when? When? 1990? Okay. So Erlang predates Haskell by 4 years, but like 4 years in the 80s, which is basically an eon. Okay. All right. So we're exporting a bunch of stuff. I'm going to guess this is just like Haskell. These are the functions that are going to be publicly available. And we're exporting more stuff. I don't know why we have multiple different exports. I don't know what dividing by 0 means in this context. It's obviously some sort of annotation. I don't know if this is like the number of processes or queues or something along those lines. But let's ask ChatGPT. That's pretty good. Add a Ferrari. Okay, so in the exports, what do the integers under the slash mean? Okay, so it's the arity of the function. So like how many arguments does it take? Good. Okay, so that's all fine. And we call this Rabbit bootstep. Maybe this is like a hook. Like these are the things that happen pre-boot. We're gonna set the description to Rabbit boot start, maybe so that you can log it. And then this is what is happening at boot, etc. Is it all just like this? We just have a bunch of boot steps. I'm not sure. Let's scroll down to under the boot steps. Well, here's Looking Glass, Tracer, and Profiler. MFA, which I think is a kind of fighting style, is set to Rabbit Looking Glass. It requires some stuff and it enables some other stuff. And I have been clicking around to highlight, and now GitHub has jumped me down here, which is, I guess, fine. We can see how long this file is. It is forever long. It's 1,705 lines. Many of them are bootsteps, about 400 maybe. About, no, 273. Okay, and then we define a bunch of stuff. These look like constants, like the boot timeout is 1 times 60 times 1,000. Maybe 1,000 is microseconds and 60 is seconds. Oh, 1 minute. Okay. So that is 60 seconds. All right. And what do we have? We have the start function. Start versus boot. We want to throw an error in start. And then start, I guess, calls start it of temporary. The restart. So temporary is a restart type. I'm wondering if this is kind of like a Haskell type definition, meaning that the restart type is a type that has 3 values. It's kind of like an enum. It's either permanent or transient or temporary. That's how I'm going to read this. That might be totally wrong, but I feel confident enough to not have to ask ChatGPT for now. At any rate, we're going to start it temporary. Whatever spec means. Spec start okay. I'm guessing this is kind of like a function declaration. Start is a thing that returns okay, or that we want to return okay. And then boot. Boot versus start versus boot. We want the node to exit in boot because applications are started with transient. Any error during their startup will abort the node. And then boot also calls start at transient. How is that different? I have no idea. But maybe it is, or maybe it was, or maybe they're just called from different places. And then we have run pre-launch second phase. Finish the pre-launch phase started by RabbitMQ pre-launch application. And so on. So a lot of this looks like lifecycle stuff, which is the sort of thing you really appreciate if you use the software, I think. But not having seen any of the other source code, I think this is mainly going to kind of just look like boilerplate to us. You know, you start some stuff, you might stop some stuff. Start apps. This function should be moved over to Rabbit plugins. Okay. Handle app error. I'm aware that like Erlang error handling is maybe a little bit different in the sense that because like you expect processes to go away, the errors are the error handling is distributed in some sense, but I'm not sure exactly what sense it is. And we have things like wait for boot. Okay, so I'm just going to move along from from that file, which I guess in other languages like C kind of looks like a main function where it's like, you know, make sure we have access to the disk, read some stuff in, call some other functions to make sure that we have like language set up. We've seen a bunch of kind of like main functions like that. So hello QSM. Maybe I can put this over here somewhere. That conflicts with me, right? Yeah, all right. Erlang, yeah, Erlang. I don't know, man. I don't know. So far, it's pretty easier to read than Perl, I think. Maybe a little bit easier to read than PHP. Is that controversial? Although I have no idea whether I have no idea whether the things I think something says are actually what it actually says. So there's, you know, I could be deluding myself. So here's RabbitMQ, where Q is like what the British people would call a line, or you know what programmers would call a queue. So we have some deprecated feature. This is just some like variable definition. It looks like, and then we define some consumer info keys, which is all caps, which sometimes means it's like a shell variable. Sometimes it means it's like a global in the language. But at any rate, we have what appears to be a list of some sort that has queue name, channel PID. I'm guessing PID is process ID, which I'm not sure if it's an Erlang process or an OS process, because I think those are different. A consumer tag, ACK required, which I'm going to guess is a Boolean that determines whether you require acknowledgements of your messages. Prefetch count. Something about prefetching messages, I guess, from the queue. Like how many times have you tried? Presumably like how many in a prefetch batch of some sort. Active, activity status, and arguments. And then we have the kill queue delay interval set to 100. 100 watts, maybe 100 microseconds, nanoseconds. We have some warning about file limits. This recover function. And I think I decided that spec was a way of defining a function signature. So I think this says that recover is a function that takes a virtual host. Maybe we can think of a virtual host like essentially a URL that this server is serving if it serves multiple URLs. And it returns what might be a record indicating some list of recovered stuff and a list of failed stuff. And recover, the implementation, will take the vhost argument, and presumably this is this is the function implementation equals. First, we set all durable to be an immutable variable that it holds the results of this function call find local durable queues on the vhost. So somewhere there's essentially like a map or a dictionary or a list that's indexed by vhost, and I guess we're just looking them up. And maybe it's not indexed by vhost. Maybe it's indexed by nothing and we're traversing the list. And then we call RabbitMQ type recover on vhost and all durable. Okay, whatever. I'm guessing recover might be a queue type. I don't know what that means though. We have this filter function, filter PID per type, and you pass it in queue PIDs. I'm guessing these are process IDs for queues. And then we're going to partition the list, presumably, given a function, essentially a lambda, it looks like, that determines whether the PID is classic. The queue PID is classic. And then you pass it in the queue PIDs. So I guess this filters or partitions based on classic versus non-classic queue PIDs. I'm getting some sort of warning about the bit rate. So let me take a look-see on this. The current bit rate is lower than something or other. Okay, so let me take a look. Let me make sure my OBS setting is correct. I think I can't change it. So if you're watching, let me know if the video is like stuttering or anything at all. I will be re-uploading recorded versions that will not stutter. Okay, great. Thanks, QSM. Okay, so then we have stop, which will presumably stop some queues. We've got classic queues. We've got this sup stop for vhost. I guess I should figure out what sup is. But we're going to call stop for vhost on the vhost. And I guess that's going to stop everything, all of the queues. Then we're going to get the environment. Passing in backing queue module, which is not passed into the stop function. So I don't know where it's defined. Maybe it's some sort of global. And then we're going to call, we get back BQ. Oh no, that's not so surprising, but we call BQ stop. This is whatever this is like something like a class or a group of functions, a module, I guess we can call the stop function on. And we pass it in a vhost. And that stops all the I guess non-classic queues perhaps. So this is not yet what I thought I would see. I thought I would see implementations of the AMQ protocol based on whatever the underlying whatever Rabbit really wants to do. And I'm just going to scroll through and see if I see anything that's like obviously we need to implement this this function based on the standard or whatever. We've got a bunch of things like number of queues, group by nodes, retry wait. We have this AMQ, we have some called AMQ stuff, which is this a separate library or is this the current library? I don't know. Let's look at the imports. I guess this is defining what is AMPQ? AMQQ. Okay, so we're including the header. I'm not sure. Let's take a look at the header. I think we can pull that out. AMQQ dot maybe it's not here. Maybe it's somewhere else. Is it another dep? We have AMQP client. Let's do a search for, I think it's called AMQQ dot header. Here's the ERL, which is different from rabbit-amqq, right? Do we have the HRL? No. Well, I'm sure that I'm just missing something. But this at least is defining something AMQQ related. This seems to be a record that has like things like name, whether it's durable, whether to auto delete, who the owner is, etc. And here's an, I guess, V2 of the AMQ standard, I guess. Another record, including PIDs and stuff like that. Here's AMQ V2 pattern. I don't know what maybe this is like a pattern that's used for pattern matching in the AMQ standard. So this looks maybe more like AMQ stuff. And then perhaps the file we were looking at before was kind of taking these records and modifying them and implementing them based on the RabbitMQ underlying queues. I could have sworn this is a thing. Can we find this? No, we can't find it. All right, well, whatever. All right, so that's enough of that. So here's auto heal. In order to auto heal, we want to find the winning partition, stop all nodes in other partitions, wait for them all to be stopped, and start them again. So is this like a network partition? What's the like cap theorem stuff? So there's this cap theorem that says you can have, I guess, what is it, like two of these, consistency and availability, or consistency and partition tolerance. And availability and partition tolerance, but you can't have all three. Or something along those lines. Is that right? Can provide only two of the following three guarantees. So I'm guessing this might be basically a network partition. To keep things simple, we assume all nodes are up. We don't start unless all nodes are up. And if a node goes down, we abandon the whole process. Okay, to further keep winning partition. What are we healing from though? Is it like the partitions think they have different leaders? All right, I don't know. We'll read on. We defer the decision as to the winning node to the leader. Yeah, I guess this is like leader election. Arbitrarily selected as the first node in the cluster. So to coordinate restarting nodes, we pick a special node from the winning partition, the winner, restarting nodes, then stop, and wait for it to tell them that it's safe to start again. The winner determines that a node has stopped just by seeing if its Rabbit app stops, if a node stops, etc., etc. Okay, so message flow. So this looks like it's something about leader election. It doesn't look like it says explicitly what happens to cause it to decide it has to heal, but maybe let's ask ChatGPT. In RabbitMQ, when does auto healing happen? And maybe this is just covered in the docs. Auto heal mode, disaster recovery, and high availability 101. How can I make RabbitMQ highly available? And what architectures do you recommend? Blah, blah, blah. So classic queues can be mirrored and configured for either availability or consistency. Okay. So availability is like, you're guaranteed to get an answer. Or I'm assuming this is exclusive or, as in you can't have both. Then consistency is like, regardless of which node I hit, I always get the same answer. So I'm guessing that reading between the lines that if you have it for availability, that you might get different answers from different queues. This is like standard behavior on the internet. If you ever have used like maybe Reddit or Facebook or a lot of places that have, for example, like likes on your post, then sometimes if you refresh the page, the like like will bounce between the light count will bounce between two values, and that's presumably because you're hitting different machines that have different views, and it has an eventual consistency design where eventually those will converge, but in the meantime you're like hitting something that has like a temporary or old value. Using the auto heal or ignore partition handling strategies will allow all brokers in a cluster to continue serving publishers and consumers even if one or more brokers gets cut off by a network partition. Okay, it is a network partition. However, on recovering from the partition, data may be lost. All right. So ChatGPT is saying recovers from certain failures or issues without requiring manual intervention. It's designed to maintain the availability and reliability of the messaging system. So we have queue mirroring, automatic node recovery. If a node crashes or becomes unresponsive, other nodes in the cluster detect the failure and take over the responsibilities of the failed node. Okay, do they restart the failed node? Network partitioning. Yeah. This just says network partitioning can happen, then automatic connection recovery. Okay, so this is like distributed system fallback stuff. So we have Gemini added a Ferrari. Okay. I'll say turn it into a poster for a film about Swedish 80s programmers starring Tom Cruise. Okay. So this is auto heal. I guess that's interesting, but I'm not sure that we want to read that logic through Erlang. We get a lot of the same sort of ideas as Erlang in things like Kubernetes. So like, whereas Erlang has these processes that can that are like quick to die or whatever, Kubernetes has the same thing but with like containers, something much more heavyweight. But overall, basically the same core concepts at a different level of abstraction. Here's Rabbit Basic. I'm just kind of scrolling down because it seems like the beginning of the file is often maybe the stuff that's not so exciting. Here's I guess a function, if I understand spec. It's going to take an exchange name, a routing key, the decoded content. I assume maybe decoded in the sense that we maybe had an encoded string and we decoded it into bytes or something. And it's going to return an OK or an error 2. I don't know what an error 2 is. Maybe it has two values. Or maybe it has arity 2. And I guess maybe it's just that it has arity 2. So it's going to give you a message, like an error message, and an any type. So I guess you can pass back. I'm not sure this is an any type, but I'm going to guess you can pass back some object that tells you more information about the message. And the message implementation is, we're just going to call make message. So let's look at make message. In this file, make message. So that's the call to make message. Here's another call to make message. And here is presumably the implementation. I'm going to guess that this is like we saw that diagram with the exchange and the queues. I'm going to guess this is one of the entry points. All right, so make message is going to take a name and the routing key, whatever this content thing is. This maybe is like a record with properties that I guess is going to be defined by the decoded content, and some GUID, probably a global unique ID. I don't know if there's any other meaning to GUID. And we're going to do a case analysis with only one case, it looks like. So if this header routes case, I guess we're going to call this header routes function on the headers. And this case of syntax is reminiscent of how Haskell also decided to do it. So if we get an error, then we return the error, I suppose. We're just calling, there's no like return, but I'm guessing like the last thing in a block or a stanza is the thing that is the return value, as in Haskell. Otherwise, we get some routes. And then we're going to try some stuff and maybe catch some errors. And if we succeed, then we return this. It's an OK object with a basic message here. And this is, I guess, maybe why the any type was useful. Because whatever the basic message is, it might be in implementations that override make message, you might get a different kind of message, like a fancy message or a topic message. So you have basic message with the exchange name and the contents that we just get by stripping the headers. And its ID is the GUID that you passed in, whether it's persistent, and some routing keys, which is either the routing keys, it's a list of things. I think, if I understand the syntax correctly, and either the list contains things that are either routes or routing keys. But I guess routing key is the thing that's passed in here. But where does routes come from? No. This is not OR. This must be maybe concatenation. Let's ask ChatGPT. Oh, I guess it doesn't like that I asked it about a celebrity. Starring a generic, handsome 80s man. Okay, so in this code block, what does the vertical pipe mean? What? It's used in list construction and pattern matching to separate the head of the list from the tail. Okay, so it's like head, tail. The routing key is the head of the list and routes is the tail. Okay, fine. We're just like consing the routing key to the list. And that's routing basic. I wonder if there are other implementations of make message that at this point, I don't remember if it was an underscore or a dash. Am I not logged into GitHub here? Let me pause this for a second. All right, so no code. Maybe, was it underscore make message? We just have the one, I guess, implementation. All right, so maybe we'll see other implementations of a similar stuff. This is Python? No, NeoTalk J. This is Erlang. I am signed in another window. Okay, so here is Rabbit channel. The Rabbit channel processes represent an AMQP 0-9. Ooh, now. GitHub. So 0-9-1 channels. Connections parse protocol frames coming from clients and dispatch them to channel processes. Okay, so we've got some channels, which might be like a Golang chan, essentially lightweight threads or lightweight processes. And we're doing message passing between the channels. And whatever a connection is, it's going to take protocol frames from the client and I guess decide and just parse them, it sounds like, and then like hand them off to the channels. Channels are responsible for implementing the logic behind the various protocol methods involving other processes as needed. Routing messages, managing queues, keeping track of consumers, etc., transaction management. So these are the things that the channels do. Every channel has a number of dependent processes. A writer, which is responsible for sending frames to clients. So I guess a channel has to write something. The channel like sends off a message to another process, and that process is called a writer process. And a limiter, which controls how many messages can be delivered to consumers according to active Quality of service, prefetch, and internal flow control logic. Okay, so there's kind of like middleware that's used for things like slowing folks down. For a beginner, what language do I recommend? That's a good question. I feel like Python and JavaScript are both good beginner languages. There's kind of like a trade-off there. So like it might be different if you are coming from like a math or something background where you have an exposure to logic or something, because the beginner languages they make it easy to get started, but then to get a lot of stuff done, you have to really dig into frameworks, and that can become its own challenge. Whereas like other languages, like maybe Go, it's possibly a little bit harder at first, but you don't like find yourself going down a rabbit hole where you really need to understand React in order to do anything. So I think that there's a little bit of a trade-off there. But for just getting started, I think I would recommend the usual ones, which are JavaScript and Python. Yeah, I don't know. It might be good to start with Go. So Go, the background of Go, according to what the Googlers have said, here from Brazil. So the idea of Go was to be like Python-like. To basically, Google was onboarding a bunch of people fresh out of college, and they wanted a language that was easy to kind of to get into the way that Python is, but didn't have the drawbacks of Python, which included, among other things, I think, just like at Google scale, like a Python app where you don't have like where you have to where you have duck typing, and it's just kind of like a squishy language that becomes costly to maintain. And I think Go was trying to be a sweet spot for getting started, but also being able to write apps in a serious way that are more maintainable. So Go might be good. I mean, I don't know anyone who started programming with Go, so I don't have enough data. But I say try it out. Try to pick up Go, and if you decide it's not going where you want it to, maybe then like fall back on Python or JavaScript. I think that somebody's got to do the experiment, and it could be you. All right, so here's the channel. So we get this record, which I'm going to think is basically like a struct. I guess this is going to be some config. But the state is either starting, running, flow, or closing. And then we have a protocol, which is the same as the reader's protocol. A channel number, I guess, I don't know if this is the same as the identifier, so you can like talk to the channel. These are the subordinate processes, readers and writers that we saw above. A PID for the connection, and so on and so forth. Source, the originating source. For example, Rabbit Leader or Rabbit Direct or undefined. And a bunch of stuff. We have a queue collector PID. When a queue is declared as exclusive, queue collector must be notified. Okay, so I guess queue collectors may be doing something like garbage collection, and it needs to know if the queue is exclusive, I guess. And so you need to know the PID of the collector so you can talk to it. And then we have some stuff with the readers. And we have another record, which is pending ACK, which I'm going to guess is we have sent some message and we want to record the fact that we're waiting on an acknowledgement. So we have a delivery tag. I guess this is how clients, this is basically some identifier for the fact that we've delivered it. A consumer tag, I don't know what that means, but maybe that's some sort of reference to the consumer. When it was delivered, the queue name, and the message ID that I guess the thing we delivered is on the queue. Maybe this is the identifier for the message ID here. And then we have another record CH, I'm going to guess for channel. It has things like a limiter, index tag, and so on. Queue monitors. Queue processes are monitored to update queue names. Okay. And then we have statistics for presumably, what are they called? Metrics. Things like reductions, PID, transactional confirm, etc. And we've got some stuff for recording stats, some deprecated stuff. Start link. Start link is going to take a channel number, some 3 PIDs, a string, some protocol, types user. So I guess a user host, an AMQP table, some more PIDs, and I guess it'll let you know if it succeeded or failed. I don't know what all these PIDs are for, but maybe these are like the reader and the whatever the writer, whatever we just saw above that told us that it had subordinate stuff. Okay, I'm going to kind of just plow along. We're at about an hour. I want to see how much we can see. Again, reading through Erlang, which is not something I've seen before. I want to see like if there's anything else that's super fascinating. And so I'm going to kind of close these files relatively quickly. Cool. Well, thank you, Nitakje. The teaching here sucks. I'm sorry, the teaching here sucks. You're in Brazil? Is that what this means? Okay. All right. So here's channel interceptor, and we've got things like validate response, validate method, validate content. So I'm guessing this really is, as the name implies, you add an interceptor to do things like reject things, like maybe authentication might be built with an interceptor. Let's see if auth is in here. No auth. But that's good enough for me. And actually, let's ask, or maybe we'll look up Erlang processes versus OS processes. Technically, why are processes in Erlang more efficient than OS threads? I'm going to guess these are just like lightweight threads. So last Chappy are Erlang processes, just lightweight threads in other languages. And to make this clear, I'll say just what other languages might call lightweight threads. I don't want ChatGPT telling me that they're not literally the same thing. Okay. Basically, they're lightweight threads. They're extremely lightweight compared to operating system processes or threads in other languages. Yeah. Is there a Wikipedia entry on lightweight threads? A lightweight process. Where's my thing that I click? Okay. We have kernel threads, performance, maybe green threads. We have also fibers. I don't know how these things all differ from at a technical level. So a fiber is a particularly lightweight thread of execution. Like threads, fibers share address space. However, fibers use cooperative multitasking. Yeah, I think that's the main thing. While threads use preemptive multitasking. And then what's a green thread? A green thread is a thread that's scheduled by a runtime library or virtual machine instead of the OS. They emulate multi blah, blah, blah. Are they also cooperative? I'll ask, are Erlang processes cooperative? They are not cooperative. So in cooperative multitasking, tasks voluntarily yield control of the CPU to other tasks at certain points. In Erlang, however, processes are preemptively scheduled by the Erlang runtime system. Okay. Fine. So they're not, so they are, I forget what the word that we just, but basically they don't have to yield. They're not cooperative, but they are lightweight. And probably kind of similar to green threads, since I think Erlang runs on a VM. Here's Rabbit Core FF. Rabbit Core. Oh, so these are feature flags. Let's just look at a couple of feature flags. One is quorum queue. Support queues of type quorum. All right, so that's implemented behind a feature flag. So as our stream queues and user limits. So let's see what quorum queues are. It's a modern queue type. It implements a durable replicated FIFO queue based on the Raft consensus algorithm. Okay, so we've got this Raft consensus algorithm, which is like a slightly cleaned up, I think of it as a slightly cleaned up version of Paxos consensus. It's more modern, but I don't know, like performance-wise, how they differ. Quorum queues are designed to be safer and provide simpler, well-defined failure handling semantics that users should find easier to reason about when designing and operating their system. Okay, so you know what? Just for fun, I'm going to add these to my reading list. So I'll also add streams and mirrored classic queues. I guess this rabbit logo is designed to look like a OK sign in addition to looking like a rabbit. Wait, there's a better way. I guess classic streams are not cool. Not anymore. So here's rabbit cuttlefish. I'm going to guess this is not so important. Sorry, cuttlefish. Here's the DB thing. And is virgin. Is virgin case? So this is some case analysis. If it is a virgin, we're going to log some stuff and call rabbit peer discovery sync desired clusters. At this point, the database backend could change if the node joins a cluster and that cluster uses a different database. Okay, so this is handling the fact that whatever it means to be is virgin. We're kind of like starting out, I suppose, because we called pre-init is virgin. And so we may, things may change, I guess, before we start writing. Here's a DB queue. Is this just a queue stored in a DB? Once amnesia is removed, all transient entities will be deleted. Okay, so there's something about transientness. Maybe we'll look up rabbit DB queue. I just want to know the kind of thing it is. Hello, regular audience attendance. How's it going? I'm glad. So whatever amnesia is, it seems like this is for transient things that are only in memory. Amnesia tables. I just deleted the existing persistent volume claim and reinstalled RabbitMQ. So every time, blah, blah, blah. All right, whatever. So get all durable is going to take a list of queues and I guess this is kind of like a filter function. When queue maybe has type AMQ queue. So I guess every queue that has like the type or the kind of being an AMQ queue, it considers durable. And I'm going to guess that what's going on in this file is if it is durable, it gets written to the database somehow. Do we have SQL? Do we have write? Write, amnesia table. Yeah, I'm not sure. So that's maybe like a down in the weeds functionalities that we'll just squint our eyes and ignore for now. Here's the DB topic exchange, which I was mainly interested in the topic exchange. I'm going to guess this is DB support for it. We can set a topic binding by calling set. And we give, I think this might be like a record syntax thing. Erlang record syntax. Do we get the hash anywhere? Creates a new record. Maybe hash creates is the new record thing. Hash record or hash symbol record Erlang. RabbitMQ uses a different protocol, by the way. Also, the consumer has to explicitly dequeue content, else it doesn't get removed from the queue. Cool. A different protocol than what? AMQ, what is it called? Is it AMQP? We looked it up before. Yeah. So I think that what we've seen, I believe, is that RabbitMQ implements like support for the AMQ stuff, but isn't. But under the hood, there's like a layer there that translates what Rabbit is really doing to what AMQ wants. Every operation like accessing, creation, and updating records are done using hash. Okay, so whatever it is, it's like some record dereferencing thing, perhaps. At any rate, so we're going to create no. Oh no. What was I looking at? I was looking at binding. Some sort of topic binding. Yeah. Okay. So we're going to give it a binding record, I guess, with the name, the source, the key with some binding key, which I'm going to guess is basically a string, and the destination and some arguments. And what's it going to do? We're going to call this amnesia thing. We're going to set it in amnesia, and then we're going to set in Capri. And is Capri their permanent database? The Capri application. Capri is a tree-like replicated on disk database library for Erlang and Elixir. Okay, so it's tree-like, but maybe not actually a tree. It's some database. You can store stuff to disk. And amnesia, I'm going to guess, is the in-memory version. And I don't know if this means that, I don't know if this is done transactionally. Like, I don't know if you can have stuff in amnesia, then the process like fails here and it never goes in Capri. And I don't think these are function calls. I think this is returning a record. And we're calling handle fallback on this thing. So do we have an, yeah, I think chat lags. I don't know. That might be something I can tune. So I don't know if we have a handle fallback thing, implementation that's accessible. But we call it a bunch of times. Okay, so can I click on it? No. All right. So somehow we've got these two things, and as I said, I think one is disk and one is in memory. Set in amnesia. And follow down create. Looks like maybe we're walking some sort of tree. We've got a try. So we've got a try, which is a type of tree, I believe, unless it's not quite a tree. It's essentially a fast tree. I don't know if it's the same as a prefix tree. I forget all the details here. In computer science, a trie, also called a digital tree or a prefix tree, is a type of k-array search tree, a tree data structure used for locating specific keys from within a set. So this is claiming it's the same as a prefix tree. So it's used for storing like things like strings. I don't know if we can get a better view of here. So I guess, so this is the root. This is why there's no letter in it, I suppose. But if you look at these T, TED, 10, they all share TE as a prefix, and more than that, they all share T as a prefix. So you can kind of walk down this tree quickly if you're searching for where a string is located in this data structure. And just for fun, I want to look up how Patricia trees differ. I guess Patricia trees are radix trees. How do they compare to tries? That represents a space-optimized trie in which each node that is the only child is merged with its parent. Okay, so things are merged with their parents to reduce the number of like nodes you have to walk, I suppose. All right, well that solves that. And so the topic exchange stuff is stored in trees, both it seems on disk and in memory. And I'm going to guess everything else is stored that way too. We have this match function. You're going to give it an exchange name. a routing a routing key and some routing options, and you're going to return a match result. It finds the topic bindings matching the given exchange and routing key and returns the destination of the bindings, potentially with the matched binding key. And so match, we're going to, whatever maps.get is, so we're going to pass in the return binding keys. What? So I guess this looks like it might be an option. No? At any rate, I guess this is some collection of keys. Whatever false means, we're going to, I guess, try to get the binding keys. And then we're calling this Capri handle fallback function, where I think Capri is the disk-based one. And we're calling match in amnesia and match in Capri. And I'm guessing this is like the handle fallback might be if it fails in one, we fall back to the other, perhaps. Let's see if we can find Rabbit Capri. I don't want to overwrite that. No, never mind. Here, we'll look at match in, I guess, Capri. We give it the transmission name, the routing key, and the whatever these B keys were, what the binding keys. And we're going to split topic key binary based on the routing keys. And we get some words. So the routing key maybe has some like paths like foo/bar/baz, and perhaps we're splitting that into separate strings, foo, comma, bar, comma, baz, or something along those lines. And then we'll call try match in Capri, where try is TRIE and not like try catch. So this is just going to presumably look in the prefix tree for that key, which is something that you might have to do someday if you ever interview for a tech company. All right. Thanks, man. Thanks for stopping by. And I appreciate the like. Okay. Rabbit exchange type. What do we have? This is, so we've seen that there's a couple of different types of exchange. And I'm going to guess this is like the implementation of some of them. We have this callback, which I don't think we've seen a callback before, but we have it's called route. And it takes the exchange, some state, and some route options. It's going to return a list of some kind. This vertical bar we determined was essentially cons. And it's going to, as in this is the head of a list and this is the tail of the list. And the head is going to be the binding destination. And then the tail is going to be a record consisting of a queue name named QQ name and a binding key. So where did this binding destination come from? I'm not sure. I'm guessing this is I'm not sure how to think about this, having this type as the first thing. I don't know if this is supposed to be like a function call signature, and this is the return type, or if this is an actual function implementation. But essentially, this record is going to be, this is the queue, and here are the keys, I guess, that go to this queue. And then this is some sort of choice about the route. All right, and we have some validation stuff we can create called after declaration and recovery. All right, I'm not sure. Rabbit exchange type. I don't see really any types here. I see this function route and some validation and the ability to add bindings. I don't know. That's a little bit different than I thought it would be. Here's exchange type direct. Oh, maybe that was like stuff that's common to all types of exchanges. So here's a specific type of exchange, which is the direct exchange. And I guess we get implementations of route. So route will take this exchange struct and the message, I suppose, that we're going to route and some options. And we're going to call MC routing keys on the message presumably just you put the routing keys in the message, and this, I guess, maybe extracts them. And then we're going to call this RabbitDB binding match routing key and pass in the type equals direct. So we're just setting kind of like a flag to this function saying what type we are. And I guess this function's job is maybe has something like a case analysis that's going to determine which queues are matched by the routing key. And if that's the case, let's see if we can find this implementation. What? There are really no occurrences? Oh, here we go. Here's Rabbit router. Is this it? We've just got the spec. I guess RabbitDB binding is where things happen. Hot path code. That's a that's a good indication. So hot path, in the sense that this is probably called very frequently, once per every message or whatever. So here's the spec. And somewhere they're going to pass in like the kind, right? I'm not sure. All right, so here's match routing key. And this is just calling to Amnesia and Capri. And maybe this is stuff we just already saw, but basically it's just going to look in the prefix tree for the destination. So that's not so exciting. Okay. Well, I mean, it's exciting, but we've seen the we've seen the background for it. And here's the exchange type fan out, which I'm going to guess is relatively similar. So we have route, and we're going to say that where we passed in before that the type was direct, here we're going to pass in this emoji, which I think we're supposed to interpret as a literal underscore. All right. Here's the exchange type headers, and I'm going to guess we just pass in the headers type essentially. So route, we're going to, oh no, we've got a little bit of implementation. Find a way not to extract X headers unless necessary. So we're going to get the headers, we're going to get the X headers, and then call Rabbit router match bindings with a name and a function. And this, I think this kind of looks like a lambda. This just seems to be like we're defining a function here that's doing some case analysis that's going to do a table lookup of, for example, I guess if you pass the X match header, and based on what you've set the X match header to, we're going to call match any with different arguments. And they all have this to arity marking. And maybe this is the implementation. And I'm not sure how to read any of this stuff, but essentially we're probably presumably going to look up the key. And this is kind of just like, we need to parse the headers and figure out which function to use. Here's a topic exchange. So this should be more or less the same as the other exchanges we've seen, except now we're going to do like prefix matching instead of matching the entire key. So do we have route? Route 2 and route 3 can return duplicate destinations and duplicate key bindings. Okay, so route is going to get the routing keys from the message and append them to some list, calling DB topic exchange match, on a bunch of stuff. On the name and the keys, and then whatever this double or is, setting R key to the R keys. This is maybe like a for each, like all of the matches where R key is being defined here. Let's ask ChatGPT just about the syntax. So what is the double vertical bar syntax here in Erlang? So it's some list comprehension filter. Yeah, okay. So I think that's what's going on. All right, so those are exchanges. Let's take a look at the FIFO thing. I don't know what DLX means. Something exchange. DLX consumer. We have some PID prefetch stuff. Checked out. I don't know what checked out means. Whether something is checked out. And then we just have like some records. Here's Rabbit FIFO header. So we have some Raft index, I guess, for leader election. And message header in memory. So, okay, so this is some macro looking stuff. This appears to be a macro. An optimized tuple. I don't know what that's about. But we're defining, I guess we have a function like is header. Is it an integer? Is it a list? We have some place to keep the raw message. We have a type for the message ID. It is consumer scoped, monotonically incrementing integer. Oh, that's the sequence number, included with a link delivery. Okay, so we have this sequence number for the message. Yeah. Then we have a message header and size, delivery status, et cetera, et cetera. But where's the actual queue implementation? We have a consumer record, an enqueuer, which appears to be a record that has the next sequence number. So that's kind of like the list structure then. For out of order enqueues, sorted list, unused, status is either up or suspected down, I guess. And then we have a block list of some sort. It's useful to have a record of when this was blocked so that we can retry sending the block effect if the publisher did not receive the initial one. Okay, I'm not sure what blocked means. Maybe we were blocked from sending or receiving or something. Then we have a configuration, including a dead letter handler, like what to do with maybe a message that fails to deliver or something. And then we have this Rabbit FIFO record with some configuration. Messages. This seems to be the queue here. We're going to call LQ new. And I guess it has, I don't know if this is a type annotation, but it seems basically be saying it's like an LQ of message. And then we have a bunch of metadata and some enqueuers. We looked at enqueuers above. So what is LQ? Is this an Erlang thing? Is it like list queue? Module index, module LQ. Most functions in LQ were copied from OTP's queue module and amended to maintain the length of the queue. LQ implements a subset of Erlang's queue module. So this is just this, a modification of OTP, I think, is the thing that people are generally referring to when they talk about Erlang. But like, I don't know if it's like the Erlang VM, but kind of like this is essentially standard library queue implementation with some modifications is what they're saying. So it's just some queue. Oh, that's good enough for me. We have limiter. I'll ignore limiter. I'm mildly curious about logs, but maybe that's not so interesting. I'm going to guess logs just go to some logging process. These are things like message records. I think we have a sense of what a message is going to look like. It's going to have a body and some headers and stuff. Rabbit nodes. We can make nodes. We can hash some cookies. I'm guessing a node is just a thing that's running. I don't know if a node is like a machine that's running multiple Erlang processes. I'll just ask ChatGPT. In RabbitMQ, what is a node? It refers to an instance of RabbitMQ broker running on a single Erlang VM. Okay, so it's an instance of the VM. Here's queue consumers. I'm gonna guess just because we're so long, I'm going to guess that this is something that we have a sense of how it's going to go. We've seen some of the channel logic. This is presumably going to connect to one of the queues and pull messages off of it. I don't know. We can do things like add. Add what? We can go to queue name, a channel. Need to remember to stop doing that on GitHub. Okay, a queue name, a channel, a C tag, a Boolean, presumably some sort of flag. I'm not sure what. Oh, we get maybe the names here. So we have a queue name, a maybe child PID, no, channel PID. Whether or not we're going to require acknowledgement. The PID of the limiter, is the limiter active, I guess. Prefetch stuff, args, is it empty, username, etc. So add might be like subscribe to a queue. Do we have subscribe? I'm not sure. These are held in our process dictionary. So we have this record, CR, I guess consumer something, has a channel, monitor ref, act tags, consumer count. This seems to be like on the server side, if we're keeping track of the number of consumers, blocked consumers, limiter. So this is maybe, instead of being like a client code, which is what I initially thought when I looked at this file name, this seems like it's server code, which would make sense since we're in RabbitMQ server, that's responsible for managing their people who are subscribed to them, the consumer, managing the consumers from the server side. A queue decorator, I don't know. We'll ignore queue decorator. Rabbit process. This has things like on running node, and this other on running node indicates if the specified process runs on a member of the cluster. Of what cluster? Do you pass it in a cluster? I don't know. You give it a PID and a Boolean or something. So you give it a PID and it returns the PID, I guess, and the Boolean. It returns the PID maybe of which node it's on and whether it's actively running, I suppose. You can check if your process is alive and whether it's hibernated. So just kind of like managing processes. A queue index, is this like a database index? A queue index is responsible for recording the order of messages within a queue on disk. Yeah, so basically like an on-disk index of the stuff that's on the queue. All right, and that's I think all of these are going to be stuff I can skip. Queue type. Let's maybe take a look at queue type. We have some state, some configuration options like whether we need to act, etc. Stuff we've seen before. Mostly, it looks like. We have some action types. Indicate whether the queue type module that a message has been delivered. Indicate to the queue type module that a message has been delivered fully to the queue. So we have settled, which has like, I guess, a success, like true or false, and a list of message tags. So I guess maybe these are all the messages and whether they were successful. Deliver, maybe these are messages in process and blocked. Settle OP. Settle op, complete, requeue, or discard. And I guess if we, maybe we settle like after retries of, maybe we retry, and then if we like fail, maybe that's counted as settled perhaps, and then we need to decide whether we want to try to requeue or discard it or something along those lines. And that's enough for me. This quorum queue thing, something about Raft. We're not going to have the time to dig into it. Rabbit router, I think we found through looking at other files. And then stream coordinator. This is probably for stream queues, which I think that they said was less cool than quorum queues, so I'll ignore it. And then we have RabbitVM. So let's take a quick look. We have this memory spec, which is a function that just returns some infos. So I guess this is like the about menu. Interesting sups. Some processes. I don't know what sums are. A bunch of stuff like workers and connections and channels. Some, I guess, information about amnesia, some stuff about quorums, etc. This seems like maybe this is like just useful information if you're an administrator. And I think that's enough for me.